All right, welcome to the 48th day of school. If you can imagine, it's been that many days. Now, we're going to go ahead and take a look at this assignment. We'll do this together, and your homework assignment is going to be a slightly different version of this, okay, which I'll post on my Fusion page. Before we go anywhere into this, there's one more property of a proof that I want to talk about, okay, especially a congruent triangle proof. And whoops, let's put it in there first. All right. Oh. Yeah, you might want to just take like one quick page of notes. So please pull out your notebooks if you haven't got them out already. CPCTC is the abbreviation, and it means corresponding parts congruent triangles are congruent. CPCTC. Okay, what does that mean? All right, what is all this math stuff? All right. If you know that two triangles are congruent, you've proven it, okay? So you've already done the proof, and you've already written triangle ABC is congruent to triangle XYZ. You've done it by whatever method, angle side side, no, sorry, side angle side, side side side, HL, whatever, okay? During that proof, you only really had to talk about three congruent parts, right? Whether they were three sides, two sides and an angle, all that stuff, right? But now that you've proven that the triangles are congruent, you know that all of the parts are congruent also, okay? So if I wanted to do, say, let's go through an example. Let's say this about CPCTC. It is almost always the last line of a proof. That's what it means. After you've proved the two triangles are congruent, then all of the other parts, all of the other things that you didn't talk about, they're also congruent. Okay? Which is why it's almost always the last line of the proof, because you have to prove the triangle's congruent first before you can use this. This is a reason statement put at the end of a proof. The The only other time that you would see it not at the end of a proof would be if they told you that two things were congruent in the beginning. And then you would say, oh, well, if they're congruent, then their parts are congruent, and I can find something else. You can do something else with this proof. But it's very rare. All right. Well, let's take a look at this worksheet. Due to a glitch, we're going to skip over problem number 1 because the picture didn't show up. So we can skip number 1, and we'll go right into number 2. All right. I'll see if I can make this a little bit bigger. Okay. So, whenever you're dealing with overlapping triangles, or even sometimes with triangles that are just touching, it's best to split them up. Okay? So, let's redraw them in different places. And what's important is to put the labels on there because that's, really important. Oh, excuse me. Okay. And now we have tick marks. We got to put all in place. All right. Now, what also do we know is congruent? Just because they were overlapping. XY. XY is the same XY in both. What property allows me to do that? What do you call that property? That's the reflexive property. So I could mark this, all right, which is extra. I don't even really need it. Because if I didn't have them, what could I use to solve, what method could I use to prove these two triangles congruent? What method is available to me right now with these two triangles? Yes, it is angle side angle. Very good. Nice. Well done. Even if I didn't have that XY segment, I could still just use angle side angle. Okay. So we've taken care of the first part. Taking care of the first part of it. And now we have to list the other corresponding parts that are also congruent. See, so now that we've said, hey, these are congruent by angle side angle, now I can talk about the other sides and the other angles because they're congruent too. That's the whole idea. So, somebody give me another piece that's congruent. Yes, we know that. We're looking for the other parts, the ones that we didn't know in the beginning of the problem. Good. What about the other parts? We didn't know this at the beginning, but we deduced it. XY is congruent to who? YX. Yes. No, that's okay. We're still missing a part. Because we've taken care of this guy and this guy. It's congruent to this guy and this guy. We're still missing one more piece. What is it? No, we're doing all the parts, all the corresponding parts. We're still missing one. What do you got? We knew AX. AXY. We already knew. Give me the one angle I don't already know. XYA, we could say. Angle XYA. Oh, shoot. Dang, image. So we're talking about, you're going from X to Y to A. So now you're going to go from Y to X to C. Oops. So those are the other three parts. How you name an angle is super critical. You've got to be able to name an angle properly. If you can't name an angle, then we can't talk about geometry. That's going to be hard to do in a geometry class. All right, so let's go to the next one. All right, so Antonio, read that off to me. Read that. What does that say in math speak? Yeah, how would you read that out loud? What does that symbol mean between the QS and the RT? Parallel. So let's go through this. And since you dodged that one, I'm going to catch you with this one. Read this paragraph to me. I can't hear you all the way over here. Nope. Because they can't hear you over here either. Go ahead. So what goes in there? RT, good. All right. Let's look. They're going from S to Q to T. So who would be the corresponding part to that? R to T to Q. And if you think about parallel lines, right, there's my transversal. And those are alternate interior angles. Okay, look for parallel lines. They give you alternate interior angles. So we're going to name this R, T, Q. Whoops, excuse me. Keep going. Thank you. Now, what we're going to have to do is plug in all the missing parts. Now, remember, look carefully what they're asking us. That's what we're being asked for. We're not being asked to prove the triangles are congruent. We're being asked to prove that two angles are congruent. So in order for us to do that, we have to first prove the triangles. Once we've got the triangles, then all of the other parts come along for free. Okay? So that's kind of a clue to let you know that you're going to use CPCTC. Because there's no quick and easy way to just say, hey, angle is congruent to angle. Yay. Especially if they're not like on a parallel line or vertical or something like that, which we already would know. So whenever they're asking for a piece, chances are it's going to be a CPCTC proof. Okay? And in fact, if we look down here, you'll see that we are. Corresponding parts of congruent triangles are congruent. Okay? So, what am I going to put right there? Good. And what else? Okay. Now, let's look at the reason for the next one and figure out what has to go in that spot. They're talking to me about alternate interior angles are congruent. So what are the two angles that we know are congruent by alternate interior angles? Right, they talked about them right here. All right, and we've done a lot of work on the reflexive property. What does the reflexive where does the reflexive property come in? Who? Which segment? QT. What's QT congruent to? The reason why they're reversed is if we went ahead and looked at triangle SQT, and then we looked at triangle RTQ, the tick marks help you. See how they arrange themselves? So what was T and Q Man, this guy's not being nice to me today. So you can see that they're reversed. They're in different positions of each other. Sometimes they're the same order, sometimes they're not. You kind of have to follow along with the congruence pattern, whatever order you're going in. All right. Number 4, something by angle, angle, side. What's it? What am I going to put before the letters? A triangle symbol. Triangle what? SQT. Okay, that works. Is congruent to who? RTQ, right? And now, my last line, now that I've proven them congruent, what do I put? Remember what you've been asked to do. Angle QTS. Is congruent to TQR. Yeah, that's what they were asking for in the very beginning. They were looking for an angle, not the triangle specifically. You know, that's what they wanted. So in order for me to get it, I had to use CPCTC. All right. Good. Angle SQT. Oh yeah. No, you see, this is a specific to whatever problem you're looking for, right? As long as you can put the first one in any order you like, but the second one's got to be in the same order. Okay, you can call the triangle anything, but you have to keep that pattern with the congruence statement. Okay. All right, moving on. Now, there are 3 different problems that use the same diagram. So that's why they say copy and mark. Copy and mark, all right? So, for the number 4, AC is congruent to DC, and angle B is congruent to angle D. Are they congruent? Can we find another piece? What do we know is also true? I got a vertical angle. So, can I prove these congruent? By what method? I don't have the reflex, there's nothing shared. What's this one? I don't know that. I don't know that. I do know that. Don't know that. I know that. And I know that. So what can I go? Angle, angle, side. You stay away from the, you stay away there. And you get angle, angle, side. Is that it? Are we good? Is that on the good list or the bad list? That's on the good list. All right, what's this one? What is this one? So does this work? They have to be the same. It does not work. They must both be the same. So this does not, I cannot prove congruence. They must both be the same. That one does not work. Put it down here for a minute. All right. Now we've got this next one. What does that mean? Number 5. Ae Bisects Bd. What does that mean? Stephen, what does that mean? Yeah, they intersect each other, but Why not just say intersect? What does bisect mean? What does bisect mean? They cross each other where? In the middle of who? In the middle of AE or in the middle of BD? BD. AE cuts BD directly in half. BD is the one that's split up. So what would the next one mean? That they, what does it mean? Who's congruent? What segments are congruent up here? I didn't hear you. What about you? Say it. They bisect each other. They both cut each other in half. And what else you got? I got vertical angles in there. So what method of proof is this? Say it again. What did you say? I say a side angle side. And the other part of the question was, how would you prove AB is congruent to DE? So, well, first we had to find out how they're going to be congruent, and then what about the segment? And that segment would be done by CPCTC. Okay, so first you're going to use side angle side to prove the two congruent, and then you're going to use CPCTC. Okay, last one. AB is what? So AB is parallel to DE. Does that mean that they're congruent too? Can I just put length tick marks on there? No. Parallel does not mean congruent. And we also know that AC is equal to EC. Well, now what? We got verticals. Cool. What do we know? I don't see tick marks on but one side of each triangle. But go back to the last example. Parallel. What does parallel give me? Alternate interior angles. So I have two lines that are parallel, and I got a line going across. Or you could do, you got this one too. So that's a pair, and these are a pair. Parallel lines give you alternate interior angles. Keep your eyes open for those. Have a good one. Kind of abusing my notation there, but it's okay. So what do we got? Look at each one. So we got more than enough information in here, don't we? So when you have more than enough possible information, you have more than 3, then that means that you're probably going to be able to use more than one method, and you just got to pick one. Doesn't matter which. If proof is proof, that's like, once you've condemned somebody as guilty, and then find more evidence, that's fine too, as long as the evidence says that, they're guilty. Right? Right. There we go. All right. So what method of proof do you want to use? You got 2 choices. You could do angle, angle, side, right? What's the other one you could use? Side angle. I could go like that, right? And this would be side angle, angle. So I really don't care what you use. Either one. Just pick one and stick with it. And then, of course, to get that, pardon me. All right, does this work? See how this goes? Sometimes they'll confuse you, and you've seen this in your homework, where there's a whole lot of stuff proving congruent. I mean, there's a whole lot of things that are given to you. You just got to pick one and roll with it. All right, let's take a break. Brain break. Take a pause for a commercial break from our sponsor. All right, we're back. That was a fantastic commercial break. All right. So first thing you're going to do is you're going to mark up your triangle. Okay. Now look at what they're asking you to prove. FG is equal to HG. All right. So right away, off the bat, if you're doing a problem like this, you could put that immediately down at the bottom because you know that's exactly where it's going to go. Okay, that's one that you can kind of get for free. Because that's the job, that's the goal. All right, what goes in the first space? Given. This math problem is so generous, it's giving us things. Perpendicular bisector. What the heck is a perpendicular bisector? It's a bisector, and it's perpendicular. It's got right angles on it, right? GK is perpendicular bisector of FH. So GK has a right angle, and if I have one, I have two. Yes, but give me a hot second on the reflexive. We'll get there in a minute. I want to attack this perpendicular bisector thing. All right, first. So what does the bisector part mean? Who's bisecting? Bisected. No, GK is the bisector. FH has been bisected. Okay, it's the thing that's been cut. All right. So who? Right. That's right. FK and H and KH or HK. And just like Antonio was saying a second ago, what do we get also? We get we got the right angle part, but we have the reflexive property because you have a shared side. Reflexive properties for shared sides. All right. Let's just off to the side. If I have a shared side, that's going to be the reflexive property. If I have a, or it could be a shared angle too. And an example would look like the one we just saw. Whereas a shared angle would look like those. That's your reflexive right there. Another one might look like that one. Those are shared sides and shared angles. Okay. Another one that we need to look at are when we say that things bisect That gives me congruent segments. Actually, not that one so much as. What's that? Nuts. Don't wait. Don't rush the Rocco show. Okay, man. Enjoy the full episode. Don't touch that dial. All right. Perpendicular bisector. That gives me right angles. And congruent segments. One second. I'm giving you all the things to look for. And what do they give you? Parallel lines. Parallel lines give me alternate interior angles. All right, these are all things that give us free stuff. So when you see them, and of course we have vertical angles. Those are congruent too. So we get some things for free. Got it all copied? I'm giving you pearls, man. Wisdom, knowledge, value, things of value. All right. All right. Some useful stuff here. This is how if you look for these things, you'll know to say, oh, heck, that means I can put tick marks here, you know? All right, let's go back to this worksheet. So, if we look at number 2, they're talking about a perpendicular bisector. And this other one's talking about perpendicular bisectors. And here, this guy's talking about the angles. It's talking about GKF and GKH, excuse me, right? So those are the two right angles. So what do you think if that's going to be? If it's also from the perpendicular bisector. What am I going to write? I've already talked about my angles. I got that. FK is congruent to HK. Okay. Perpendicular bisectors give us two things for free. All right, what about number 4? Reflexive property of congruence. Who's congruent to who? That talks about the reflexive. Who? GK. Where are they going? G corresponds to G. So what method of proof can I prove the two triangles congruent by? Side angle side. Very good. I'm sorry? Well, after... Huh? I'm confused now. Yeah, I'm lost now. Yeah, they're talking about the now that I've proven all these things are congruent. Now my triangles are congruent. Right. Yeah. No. We don't know this. We need to prove that. We can't use it as part of the proof. They didn't give it to me. They asked me for it. No. Read it. It says, given GK is the perpendicular bisector of FH. Where do you see that? No. Triangle FGK is congruent to triangle HGK. No, because F corresponds to H. G corresponds. You see, yes, I know that. No, because they're not talking about segments in number 5. They're talking about the triangle in number 5, right? The triangle symbol. Okay. Play nice, man. All right, it's a valid question. He wants to understand it. So I'm not gonna. Yeah, let's not give him a headache for it. All right, next. We did this. Okay. Gosh, we burned right through that one pretty quick, didn't we? All right. Well done. All right, last one, I think, isn't this? Yeah. All right, good. Now, let's first pay close attention to the given statements and what they want. If it's a rectangle, there are some things we know for a fact, right? What are things that we know about a triangle? We got 90s. We got right angles in places, right? And we're probably going to be talking about these triangles, so I'm not going to. I could write these up here, but I don't really need to. What sides? The top and bottom, and they also told me that somebody's a midpoint. So what does that give me? What do midpoints give me? Which congruent segments? If D is the midpoint, ED and DC, right? When you have a midpoint, you wind up getting two segments that are the same, right? Same idea behind a bisector, right? Something's bisected, it's gone through the midpoint. Yeah? Cool? Awesome. So What method of proof am I going to use for these two triangles? Side angle side. All right, great. So let's go through this. What do we know is going to be the very last line? Right. CPCTC. All right. Sometimes it's easier to kind of do these in reverse too, but let's go through it. We got the given stuff. We know that AED is congruent to BCD, right? AED and BCD are congruent. We know that because they're both right angles, right? We knew that from the definition of a rectangle. AE and BC, we mark those up because of a rectangle. What other thing, tick mark, did we put down? ED is congruent to, who's ED congruent to? CD. How do you know that? Definition of a midpoint. Now what am I going to put in number 5? Who? Look at your other examples. What did we do in the second to last step? Triangle something, 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 right? Triangle what? Congruent to who? BCD. By side angle side. How's that feel? Not impossible, is it? Which part? Okay. If you, let's go through this and do some steps. Let's take one last bit of notes. We have time. One, you mark all of the tick marks that you get from given statements. Wow, I'm good today. Now, so like if they tell you that AB is congruent to CD, then you can just put a tick mark on AB and CD. But sometimes you don't have given statements, you know some geometry, like you know that these two angles are congruent because they're vertical, right? Or we can put a tick mark on something because of the reflexive property or something like that. So you put your vertical angle marks, you put your alternate interior angle marks, from the, anything that you found through the geometry you know. Then we make a decision about, is it side, angle, blah, 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 whatever it needs to be. You kind of have to decide what it is. So you got to pick one of those 5. Now, once you've decided it, you're going to list a congruent statement for every tick mark. Well, first, you're going to write the proof. First step, write your givens. Take a message. I'm not here right now. Thanks. No. Write the givens. Bless you. So if you're going to do side, angle, side, I need a statement for the side. I need a statement for the angle. I need a statement for the other side. Got to have 3 statements. That's it. So you do all your tick marks. You decide how it's going to be done. And then you list it all. All right. Going to give you guys a similar one. And this episode of the Ronco Show has been brought to you by our friends at CPCTC.